Yeah.
Okay, thank you. So today's webinar is on GeoPackage and KART.
I'm sorry, just could you just remind us your role in BMT, because I don't know the full extent of your domain.
So I'm one of the developers on TUFLOW. I've been at TUFLOW for 6-7 years now, almost 7 years, I think. I do a range of development, so I do a lot of development in TUFLOW. I've also developed in TUFLOW FV, and as Duncan said, in the TUFLOW catch space, I've done a little bit as well. I'm also the primary author of the TUFLOW plugin in Qgis, and also the primary author in some of the other tools as well. So in ArcGIS, there's a TUFLOW add-in. I wrote that add-in as well, and I loosely maintain the map info code base as well, which is quite old. That was one of the older add-ins we have. So my background is in consulting, so I spent about 7 years in flood consulting before moving to the TUFLOW team, and primarily, well, entirely in Australia as well, before moving to the UK, which is where I am now in Leeds.
Okay.
Somewhat sunny, but it's somewhat cloudy as well, Leeds at the moment.
Thanks.
Yeah. So I do a lot of work in the GIS space. So obviously in QGIS, ArcGIS, and a lot of the GIS integration in the moving forward from when I joined. I do a lot of that now. So that's why I've been invited to talk about GeoPackage, which is a GIS format, and KART, which is a versioning format, which we'll get into. So I guess I have a question, rhetorical question, or answer to yourselves. Does your TUFLOW folder look like this? TUFLOW or whatever modeling package you're using, I suppose. You know, mine often does. When I get stuck into a project for too long, if the project goes on for too long, organization starts to break down a little bit. Especially when you're trying to, you have deadlines to meet, you're trying to rush out modeling runs, you end up foregoing some organization just to get things going, and things get very, very messy. If you're really good, then, you know, does your folder look like this, a well-organized file system? If your answer is yes, then well done. I might not necessarily believe you, but good work. But this system here, the old KART catalog system, is quite old. Like, obviously most libraries now, to some extent, at least in the public areas, and hopefully in the back rooms as well, where they do organizing and stuff, have moved past KART catalogs. Obviously this photo is a black and white photo just to show how old it is and what people are wearing and so forth. But hopefully we can move to something a bit more modern. I mean, this isn't necessarily modern. This looks like a 2000s setup when I was going through school. Can we move to a digital system, like a bit more analogous to this, or even a much more modern system, which is something, you know, using tablets and stuff, analogous to that in our modeling folder? So I will be presenting some of my ideas today, and that is essentially using a formalized version control software. And to do that, we'll be using GeoPackage, or you have to use GeoPackage, which is a vector format, like a shapefile or a replacement to shapefile, and also KART and Git, which are version control software. So I'll start the presentation by just giving a recap on GeoPackage, just to make sure everyone's up to speed with that format, and then I'll go into some stuff about version control towards the end. So what is GeoPackage? It's essentially an SQLite or SQLite, some people will pronounce it, database for storing geospatial data. So it can store things like vector features, which is, you know, the equivalent to shapefiles. Primarily is what I would be using GeoPackages for, but it can also store things like imagery data, and non-spatial attribute data, so just tables of attributes essentially. But it also supports a number of extensions, both sort of formalized but also user community-based extensions. An example of this is a formalized extension, which is pretty much used by everyone, is the spatial indexing extension. And there's also community extensions, which is one that we use in TUFLOW is the gridded dataset, which is the essentially the DEM, like where you might store terrain data, as opposed to imagery sets. You store digital elevation model data in GeoPackage. It's just I just want to note that SQLite is one of the most widely used libraries in the world. So it's literally on everyone's smartphone. It's probably on everyone's computer several times in various different applications, programs. So it's not some obscure database format. It's actually a library that it's probably up there in the top 10 most used libraries in the world, up there with like the deflate compression method, which is the default zip format that zip uses for compression. So it's a very well-known, very well-used, robust format and library. There are more complicated databases, and that could be used as well. But at the moment, TUFLOW just supports the simple one of GeoPackage, so it's very easy to set up. So what does it actually look like? Well, it's a database, so it can essentially store multiple layers inside a single file, which is essentially going to be what I call a database, or what is called a database. So the equivalent of this, which is what your TUFLOW GIS folder might look like currently, which is made up of your GIS layers, which are all shapefiles here, which can get quite messy. This is a very clean representation. Only the modeling layers that are actually being used in the model are shown here. But you can imagine, or you might not have to imagine, you might experience this yourself many times, this folder getting very, very messy or very, very big, hard to find anything, because essentially you have a bunch of files and superseded files that aren't even used in the model anymore in this folder. Whereas over here, we just have one file that contains the layers. And you don't have to have one file. You could have multiple databases, and you can group your layers together in those databases however you like. But even if you were to just have a single layer in a single database, it will still be a lot cleaner, simply because at the very least, you don't have all these associated files with it. It's just a single file. So a lot cleaner already. By just switching from shape to GeoPackage, you get a lot of cleanliness straight away. In terms of the TUFLOW side, it's a little bit different. Command-wise, if you're familiar with TUFLOW commands, which I hope most people are who are in this webinar, but essentially you have to point TUFLOW to the database file, the relative path or full path to the database file, and also the layer name within the database. Since the database can contain multiple layers, you need to tell TUFLOW which one you want to use. So you have the standard TUFLOW command on the left-hand side, and then you point to the file path, which is the GeoPackage, and then you'd use this angled bracket, double angle bracket, to tell it which layer to use. So the syntax changes a bit. If they are the same, you can sort of reduce that command to just the database file, and TUFLOW will assume that this part of the name is the same as the layer it's looking for within the database. Same with the projection. So when you're setting up a TUFLOW model, you usually tell it what projection you're using, whether that be shape, MIF, and now GeoPackage. So with this command, it's the same thing. So you essentially point to the database, and it would assume that there's a layer called projection in this case, or you can use this syntax up here on this command as well. Where you have TUFLOW commands that accept multiple layers, so examples of Z-shape, which is a break line, or terrain modifier, where you want to read in different geometry types, or a line and a point, and maybe a region, whatever else in a single TUFLOW command. You can sort of narrow it down. You can sort of reduce this command by using the double ampersand symbol to say, I want to grab this layer and this layer from the same database. So it just reduces the command a little bit. Usually you'd have to have some command path, vertical line, and then the next file path. You can still do that with Geopackage, but just by using the double ampersand, if it's in the same database, you don't have to do that big extended command. But this is my preferred approach. If you're using sort of a centralized database, even if you're breaking it up a little bit into several centralized databases, this is still a really good approach. Essentially, you just have one new command in TUFLOW in any of the control files, which is spatial database equals, and then the file path to the geopackage. And then subsequent commands, which read from the database, just have to point to the layer name. You don't need to do the full path each time, which is a really nice, clean way of reading these commands in. So one of the benefits, besides obviously the cleanliness, where you can just group single layers into a single file or a few select files rather than having them all just spread out. Well, it's spatially indexed. I said being spatially indexed was an extension. It is an extension, but it's one that's pretty much adopted by every software out there that uses Geopackage, because you'd be silly not to use it, essentially. It's a lot faster to view in GIS. So just as an example, I've got a little video here that shows this. So we have a 46.5 million point data set, and this is the example of trying to load that as a shapefile in QGIS. So you'll see my cursor come up on the screen and drop that in. And it takes about 5 seconds to load, so I'll probably just hover around the time here so you can see how long it takes. So it takes about 5 seconds maybe to load that data set into QGIS. It's not actually too bad. You know, you're zooming in, there's a bit of a lag as it tries to figure out what to display. But overall, not too bad to sort of navigate. The issue comes in when you try to just query anything or do anything with this data. So you see I just infoed a point there, and it takes about 45 seconds. So 45 seconds is actually a really long time, I found, when I'm sitting here talking or waiting in silence. So I'll actually speed up here because I don't want to make everyone sit through that. So 45 seconds later, hopefully something will happen. It's not frozen there. So it finally figures out which one I'm trying to query, but it's grabbed 2 of them, which is annoying. So I have to query it again. And 45 seconds later, which takes us all the way probably around here, it'll figure out what I want to do again. There we go. So very, very painful. And then if I want to select anything, again, that's just going to be about a 45-second wait with this data set. It's going to take us pretty much to the end here. 45 seconds later, it's figured out what I want to do. So viewing is not too bad, but if I want to do anything with the data, it becomes untenable, very, very painful. Same thing, the exact same data set, I've just converted it to a geopackage with just GDAL, which is what's built into QGIS. So just using the default settings, nothing special. Play that, so load it in. Pretty much loads instantly. Zoom in. There's really no lag in displaying anything on the screen as I zoom in. Querying things, pretty much instant feedback. So very, very fast compared to the shapefile equivalent. As I play around with it, of course, when I zoom out too much, there will be a slowness as QGIS tries to render it, which is not really the format's issue. That's just how fast. That's just mainly trying to find and render every single point on the screen. So if you zoom out too much, then you obviously have a lot of points to render. But that's done. Like that whole video was less than 45 seconds, which is, as I said, the time it took to do anything with the shapefile. So that's the benefit I see. So even if you're not using Geopackage as an input into TUFLOW, you can use it as an output. And those really big check files that TUFLOW writes, the Z-point check file and the grid check file, are easy to view. Then you can actually go and use them a lot quicker than you would do with the shapefile, or hopefully no one's using a MIF file anymore. So very fast to view in QGIS or other GIS software as well. Out of TUFLOW, it's about 3 times faster to write than shapefiles. So if you're writing those big check files again from TUFLOW, you're going to notice a big speed up in those being written. It's an open format, so it's more universally accepted than proprietary formats. So obviously shapefiles are very universal. I think, probably some microwaves now support shapefile formats that they're that universal. But certainly we want to move away from shape and move to databases. So more to the equivalent you might say is the geo database in Esri or ArcGIS. Those are probably bred in a fair few places just because a lot of software use ArcGIS in the background. But in terms of other open formats, open software, geodatabases probably wouldn't quite be as universal as something like the GeoPackage, which is also probably the go-to software in the open GIS community. It's the modern, what I would call the modern format for QGIS and other things like that.
Right.
And then finally, the other final benefit is the version control aspect, ... leads me into talking about version control. So what is it? So this is, I'm just going to read the definition which I found online, probably from Wikipedia or something. It's a system to track changes to files and the ability to rewind to a previous state. So what that means is you should be keeping a history of every single file. And I would guess that most people are actually doing this step, but manually. So in TUFLOW world, a lot of people would be having a number on most of their inputs, and then when they make a change, they would increment that number to the next number, say, and they would keep the old file and retain that state. So most people would be having some form of version control already with their modeling practices, whether it's TUFLOW or whatever other modeling software they're using. But it's a very manual process, making sure to save it as and keep it, and things like that, which can be a little bit painful to do manually. With a version control software, this would all be done for you. Version control would inherently keep a backup of your project. So what this means is, like, because of the way they work, you have a version in various different places. You'd have like a repo somewhere, and then you might have that repo cloned onto a bunch of different people's computers, and that sort of keeps a backup of your project. So if it crashes on someone's computer or becomes corrupted, you could just grab it from the repo again or from someone else. The ability to view changes or view the history is very, very powerful. So you can do this, of course, with the manual method, but it's very, very painful to do, or a lot more manual to go back and figure out which files belong to which version. So you might have a TCF file that's increment number like 30, and you have to figure out, okay, 30 belongs to number 25 for the TGC and 10 for the TBC, and you need to figure out all those different things, and then look at the changes with the previous version of the model. So the previous model, you have to go back and figure all those things out as well. With version control, it'd be very easy to see the current changes, but also changes between different versions. The ability to experiment in a siloed environment. So what I mean by that is the ability to sort of branch your model version, do whatever you want. You might experiment, you might build the biggest dam in the model just to see if it makes any difference to the mitigation you're trying to do. And if it doesn't work out, or if it does work out, you can then go back to your main model where you're not doing any experimenting, and you can get the version control to switch between these branches instantly, and it'll just go back to the state of the model before you branched it, essentially. Or if you do want to adopt the changes in your branch, it's very easy to merge that into your main model. It's very easy. It makes collaboration, model collaboration or model building collaboration, very easy. Either if you're collaborating simultaneously with your colleagues, or maybe not simultaneously, but it's very easy for your colleagues to grab versions of the model and build, and then push and pull those changes into a centralized database. And traceback. So what I mean by traceback is sort of similar to the first point, is that you can actually go quite granular with your viewing of a history of a file, like line by line. You can go to a given line in, say, the TCF file and see when that line was added and who added it. in Git, it's called git blame, but we're not trying to blame anyone here, but it's just it's a good history of different edits people have made to a given file. So very, very useful when you're trying to figure out where things are going wrong or when something was added, if it looks a bit suspect. I just want to quickly go through the workflow, the general workflow of version control. So this is something that software developers use and probably will be very familiar with if anyone's dabbled into that. So I just want to go through the general workflow and also some of the general terminology and setup of version control before I jump into the specific TUFLOW or modeling examples of a workflow that you might use. So the first one, just quickly talk about the software. So Git is a version control software used for just plain text files, which software developers have been using. It's probably the most widely used version control software. There are a few others out there, but this one is probably the most popular, most modern, and especially for open source project, is probably the go-to at this time. And then there's KART. So KART is the title of the webinar, or part of the title of the webinar. It's the version control software used for GIS layers. So it works for Geopackage. It does work for a few other formats, like PostGIS. And I think now it can do some other database formats. But Geopackage is obviously read in by TUFLOW, so it's perfect for TUFLOW modeling. And you don't, PostGIS, you have to set up servers and stuff for that database, so it's a bit of a pain. KART is actually built on top of Git, so they're very similar because KART uses Git as underlying libraries. So they actually work very well together, these two pieces of software. So to go through some of the how it works, we usually have a repo, or sometimes it's called a remote, or sometimes it's just the origin. There's probably some key differences between these words and terminology, but I'm not going to go into it. I don't know exact nuances between why you would use remote over origin or whatever. But essentially, you'd have some central location, maybe on the cloud or on the network or some server somewhere, which would hold your model. When you want to grab that model and make changes to it, you'd actually pull that down locally onto your computer. So this would sit, say, on your C drive somewhere, and these are the modelers, say, and they're pulling from this one to get the latest changes, or initially, if you want to just grab it for the first time, it's actually called cloning the repo. Either way, you're just pulling it down and getting the repo locally on the computer. And that's where you make your edits. And then when you're finished editing and committing and so forth, you then push to the remote. So that's when the origin or the remote or the repo is actually updated, is when you're happy with your commits and you push it up there. And that's when, so say this is person A, they push their changes, person B and C and whoever else can then pull and get those changes locally on their machine. And every time you do this, it's only pushing and pulling the changes. Like, it doesn't have to push and pull the entire modeling database or the database down. So it's a lot quicker than copying the model around, because you just don't have to do like gigabytes worth of data transfer each time. So it's a very quick and easy way. You don't need to worry about checking save dates, making sure you're grabbing the right files that have been edited. Like, all of that should be taken care of by Git or KART. So I just want to make the distinction that there's an origin or a remote, and there's also a local copy on everyone's machine. Within the local copy, there's a workflow. So when you're editing a file, so I'm looking at plain text files now, so pretend like this is the TUFLOW control files. When you're editing the TCF file or the TGC file, this is what we call the working copy. This is the copy that TUFLOW will read, or in software development, this is the copy that will be compiled into an executable or whatever. These are essentially the files you're working on. Then you have this interim step called the staging area, where you say this file should be committed in a moment, and then you have a commit. So it's a three-step process of editing, staging a file, then committing a file. And then you have this concept of head, which is just like the head of the commit. So essentially just means the latest commit. So if you're working this, if you go away and work with Git or KART, you'll probably see the word head floating around a little bit. That just means it's the latest commit. That's all. And then you can go back, of course, after you commit, you can go back to step 1, start editing some different files, stage, commit, and you can repeat till you're finished. And then you can do this. You don't actually have to push your changes straight away. You can make as many commits as you like before pushing those changes up to the remote or origin. Just remember, commits are just local to your computer, so no one else can get those commits until you push it to the remote, and then other people can then pull your changes down as their own copy and do their own work on it. So the idea is you're working locally until you're ready, then you push it, and then other people can access it. KART, being very similar as it's built on Git, has the same 3 stages. The working copy is the geopackage, and it can only be a single geopackage. So the repo is associated with a single geopackage database, which TUFLOW will read from. And then the staging area, the only difference is the staging area is largely invisible. You don't really need to worry about that. Essentially, you edit the geopackage, then you commit your changes. You go back, edit a geopackage, commit your changes, then you push that up to the remote. That's the generalized workflow of just version control in the software, and it's pretty similar with other version control software as well. You have these steps. They might be a little bit different how they do things, but basically those are the steps. So going into a specific modeling example with, in this case, TUFLOW, I suppose it would work with any software that can read in geopackages and uses plain text files. But effectively, we're going to have 2 repos. We're sort of forced to do this because we're going to use 2 different versioning software. Although they are very similar, they are 2 different software, so there are 2 different versioning repos that we have to set up. So we'll use Git as an example for our plain text files. So luckily, TUFLOW uses a lot of plain text files. The control files are all plain text, and even our database formats are just CSV files or comma delimited files that are just plain text. So they are perfect for version controlling with Git. In GIS world, we'll be using KART. So remember, this is a separate repository, and all our GIS layers, so your inputs like your 2D code, your 2D mat, whatever else, Z shapes, 1D, pipe networks, everything is going to be done in GeoPackage. And just recently, I don't know exactly when, between this time last year and now, you can actually can version control geotiffs as well, which is really nice. So you can actually put your geotiffs, which TUFLOW can also read, into KART. It doesn't store that in the geopackage, it stores it next to the geopackage, but it will version control the geotiff. And then, of course, you have a bunch of unversioned files. I note this just to make sure. This is just typically the workflow. Outputs you wouldn't usually version control. So the same with software development, the compiled executables and or libraries aren't usually version controlled. It's the source code that's version controlled. I imagine the same thing would be happening with modeling. You'd version control the control files and the inputs, but the outputs, check files, log files, XF, which are the binary cache dumps that TUFLOW uses, rainfall grids and empty files are all generated by the person. So when you pull down the model, you have to generate them yourself, or you might have them stored on the network somewhere, but you probably wouldn't get Git or KART to version control it. The only thing missing really that I could think of is tins. I'm not sure if people use tins. I guess most tins that TUFLOW support, so like the land XML is just a text format, would probably therefore have to be versioned by Git. That's probably where I would stick it. In terms of the setup and TUFLOW setup, so nothing really changes. If you're doing TUFLOW modeling really has 2 stages. You're using something like Notepad++ for your text files, and Excel for your CSVs, obviously, or something like Qgis for your GIS stuff. that workflow really doesn't change. In fact, it's enhanced really, but largely it's not changed by simply using version control. So in this example, I'm going to be using VS Code, not Notepad++, just because VS Code has probably slightly better Git tools built into it. There's probably some Git plugins in Notepad++. I've not tried them, but I just know VS Code does have good Git tools natively built in, which makes it quite nice to use with version control. So VS Code is completely free and it's just a little bit more heavyweight than Notepad++, but not much more. So it is probably an easy thing to just adopt, to switch over to use. You're not really committing any, you're not paying for it or anything, essentially. There is syntax highlighting libraries. It uses what extensions, plugins, extensions, same thing. It uses extensions, and there's a TUFLOW extension in there as well. So you're not missing out on the syntax highlighting from the Notepad++. In KART world or JS world, obviously Qgis, the TUFLOW plugin, of course, and then there's a KART plugin, which is really good. We don't develop it, of course. This is developed by third party, but it's very nice, very good plugin, and it sort of keeps everything that you're doing inside Qgis, which is really nice. So when you're committing, you're looking at differences, you're looking at the logs, you're reverting, you're branching, all this stuff can be done inside Qgis, which is really nice. You don't have to sit there on the command line doing all this manually, which is a bit painful. This time last year, I said you had to use Git Bash, or Git Bash for Windows, technically it's called. That's no longer the case. You don't actually need that anymore, which is great news, which was a bit of a thorn in the side of this workflow where you had to actually jump outside of Qgis to do some pushing and pulling. I was testing this last night and a few days leading up to this webinar, and it can be completely done now. Pushing and pulling can be done in KART for like things like the cloud, using cloud services like GitLab and GitHub. Really nice. So I would say nothing's changed other than some of the workflow has been enhanced. You don't have to do a bunch of incrementing and saving as and copying files to change the file name and stuff like that. Talking of GitLab and GitHub, I'll be using these in the example because I think they're sort of the end goal, like the final ideal world we'd be using these in modeling. So that's what I've jumped to. It doesn't have to be. I think you could use your own server, or you can actually use a network drive to do this step. But GitLab and GitHub do offer features around Git, which are really useful. So essentially, if you're not aware, you might have heard of things like GitHub before. If you're not familiar with it, and Git, you still might have heard of GitHub. They're essentially just cloud storages for usually code, like software code, that offer a lot of features around it as well. So they do a lot of nice displays, and they have services like issue trackers and boards and stuff where you can assign people tasks and move those items around to say they're in progress or done. And it makes like a review process very easy as well. So I imagine doing something like that in modeling would be really handy, sort of just force model reviews and things like that. For this example, I've chosen GitLab simply because we have some good stuff for TUFLOW in GitLab. It seems to be our chosen service of choice. But I've also tested in GitHub. We have a GitHub account as well, and I've tested it over there, and it also works completely the same in GitHub. And both these services offer free services up to a certain license, depending on what you're doing with it. So it's definitely easy to test these services if you wanted to go out there and try it. So there's no cost commitment to these either. When I was setting this up, I have written down my steps. So I'm not going to go through everything that I did to set this up. It's a bit technical and a bit boring. But there are some, at least when I was doing this initially last year, there were some little details that you had to do. I think they've actually ironed a lot of that out now. But there are a few little nuances that you need to go do. So I've actually listed my steps on this wiki page, mainly for myself, because I always forget what I did, but also other people can go and benefit from me recording these steps. But effectively, for this example, I've set up 2 repos, as I said, for this Camelford model, which is somewhere in England, West Coast. Duncan might get angry if I get that wrong. West Coast of England, somewhere. And essentially, there are two repos. So there's the Camelford repo, which is the Git repo, which holds the control files and like the database, the CSV files. And then there's the GIS repo, which holds the KART stuff, which is like the vector layers and the grid layers. So it's a bit annoying. You have to set up 2. I'll mention in my wish list later on, I don't want them to be 2 different things, but at the moment, you're forced to have 2 different repositories. What do they look like? Well, locally on your computer, they look like just a TUFLOW model. So this is on my C drive. It pretty much looks like a TUFLOW model if you're familiar with TUFLOW models. The only thing is there is this hidden Git folder here, which is just what Git's using. It's just the repo information and stuff being stored inside this folder here. You don't really need to worry about it. I'm just pointing it out because it is there, and that just signifies that this is a Git repo. The other file that you might be curious about is the .gitignore, which essentially is just a file. It's not required or anything. It's just a file that tells Git to ignore certain files. So, don't try to version this. Don't complain that it's not versioned. Don't tell me about them. Just completely ignore these files. And these can be folders as well. So essentially, you would just say ignore the results folder, ignore the check folder, ignore the runs log folder. Don't try to do anything with those folders. So that's what that file is doing. And then this, that's a VS Code workspace, and obviously that's a QGIS workspace. You don't really have to worry about those too much. On the GitLab server, or on the cloud instance in this case, it just looks like this. So you can see it just looks like a normal folder structure, minus the results and check file. In here, you can do things like see the commits. So there's only 1 commit in this history, but if there was more than 1 commit, you could go to that history and look at the commits and the messages, and you can see what has changed between commits and things like that. So you can see here, it just tells me the latest commit at the top, and it's just by me. And it's just me setting up the repo for the first time. In terms of the GIS folder, so this is within the model folder, model GIS, which is where you would store your geopackage usually. This is the KART repo folder. And you can see there's a geopackage sitting here, which TUFLOW will read in. So that's the one you're pointing TUFLOW models towards. And then again, you have these 2 files, which are sort of associated with the repo, which you don't really need to worry about, but they are there. And then these 2 obviously are just TUFLOW. XF's the binary dump, as I said, and empty folder contains the empty GIS files, as those familiar with TUFLOW would know. In terms of what it looks like on GitLab, it actually understands what's being versioned on GitLab, so it actually lists out all the different layers that are being version controlled. So you can see the 2DSA, which is the source inflow, 2D boundary conditions, material layers, and plot outputs and set shapes, all that actually listed here on the GitLab server. Again, you can go to the commit history. So I've got 9 commits on this one. So you could go and you could technically look at all the different commits I've made, the history of the model, and so on and so forth. So that's why I think I would encourage, or I would want, if people were to adopt this, to use something like GitLab or GitHub, because it just makes interacting with Git and the history of the model incredibly easy, because it just is set up to work with it and show you as in a user-friendly way the history of the model. Okay, let's get into the actual workflow. So the model's set up, but obviously it's not complete. So this is an example workflow of me using it in the model build process. So this is the main branch, what we call the main branch, or in this case, I haven't written it in here, but this is the origin. So this is what's sitting on GitLab. I want to go and I want to continue building this model. So the first thing I would do is I would pull the latest update. So these circles on the timeline will represent commits. So at some commit I'm going to pull, so these 2 dots are identical. These commits are the identical commits. So I now have the latest updates of the model, and I want to go and I want to make some more refinements to the geometry. I want to go and make sure that, roads, levees, everything else is enforced in the model, so that, typical modeling, hydraulic modeling stuff, I want to make sure water's flowing correctly. So I jump in, open up. This is just some advertisement for the TUFLOW plugin. This is the import empty tool in the TUFLOW plugin. If you're not familiar, essentially I'm grabbing the 2D Z shape because that's what the layer used for break lines. The run ID, not particularly interesting in this case. It's a bit of an odd name that I chose in this example. But the key is this option down here has been added. I think it pops up if it detects you have KART installed in your system. Otherwise, I don't think it'll be there. And it should also find this file path based on this. So if it notes that this is a KART repo folder next to the empty folder, then I think it should auto-populate. Essentially, you just have to tick that on if you want to import it into your KART repo. So you don't use this one if you're doing this, just because adding a layer to the GeoPackage is not the same as adding it to the repo. You actually need to go through KART. You need to do this import step into KART to get it to be added and version controlled. If you don't do it, there are ways to fix it, of course. But I just note this, that if you're importing empty through the TUFLOW plugin, there's a convenient way to do it now. You jump into Qgis, do your break lines, which are the orange lines here. I made a sizable effort of choosing appropriate break lines for this demonstration. Make sure, the modeler and me wanted me to do a good job, so I went in and spent some time until I got bored and drew my break lines in this model. Obviously focusing along watercourses. And then I committed it. So essentially, this dot here represents my commit. And if using the KART plugin, I can look at the history of the repo. So you can see the latest one at the top is that it doesn't say it there in this screenshot, but I think it does now. It says this is the head, so it's the latest one. And you can see the commit message is import 2 datasets, which is the 2D Z-shaped layers I imported, which are the line and the point layers for the break lines. And then you can see that the main branch is actually a commit ahead. So these red dots over here represent commits. The origin branch is actually a commit behind. So that's referencing the fact that the main branch is sitting at this commit, and my local branch is actually a commit ahead. So that's why that's tagged as the main, and that's tagged as the origin main, which is a commit behind. I'm going to continue to update the model. So then now I'm jumping to the control files. Of course, I need to go to the TGC file, add my break lines, add the command there, so line 34. Just pretty standard TUFLOW stuff if you're familiar. I add the command at the bottom. Because I'm using a spatial database and a single set spatial database, I've referenced that spatial database in the TCF. I just have to reference the layer names in here. Once you save it, VS Code will actually recognize that there's been an edit to this file, so it'll show up as orange, and it'll show up here on the left-hand side in my source control panel as changed. So it'll say, hey, this TGC has changed. So then it's a matter of adding it. So now you can see, remember, there's a staging area. It's in the stage changes, so it'll be committed. If I commit, I add my commit message, and then I just hit this big commit button here, and it will be committed. And there's a history. You can look at the history in VS Code as well, so you can see similar thing. There's an origin main, and there's a main, which is a commit ahead. So similar sort of thing. Look at the history there. So that's a commit. I'm done a commit there, and these are what I did. I added a couple of break lines and updated the TGC. I want to do some more refinement, so I jump into Qgis, make a change. Essentially, I noticed that I accidentally drew a line over this waterway, blocking it with my break line. I want to go commit these changes. I want to double check what I did. So KART plugin actually has a nifty little way of viewing what you've done. So it's a simple like 2-click process of right-clicking and then choosing, show me the changes. And it'll show me, so I essentially split this line. So this is why there's one line being added and one line being modified, it says. Because I split one line into 2 lines, that's why it shows one added, one modified. But essentially, there's my line, and you can see in this video, there's an old version, and as I slide towards the new version, you'll see it shows me what's changed. So in the new version, there's a gap there, and in the old version, it's a solid line. So very nice little GUI element to the KART plugin, which I really enjoy. That shows you the changes. Obviously, in this case, it'd be really obvious to me as I was doing it, but if you make a lot of changes, you can easily see, sometimes you just need to review those changes to make sure you're not committing anything that you don't want to commit. But it also makes reviewing models really easy, as like you can go to an old version and compare commits and say, okay, what changed? This makes it really nice to be able to actually see what's changed between commits down the track. So anyway, that's a really nice little feature in the plugin that I enjoyed. So that's that commit. So then it's just a matter of right-clicking the layer, or you can right-click the repo as well to do the same thing. Click commit, add your commit message, hopefully meaningful, and that's another commit. So as you can see, the model build process continues from there. My colleague Duncan comes along. He thinks I'm going too slow. He wants to help out. He asks me to commit my changes, or push my changes, I should say. So I push my changes up to the remote, so he can pull those changes onto his computer, and then now we can work simultaneously on the same model. So as we go along, we're both working. Duncan's adding some historic events to do some calibration runs. I'm continuing doing the menial task of adding material layers, digitizing material layers, doing the boring tasks, obviously. And then at the end of the day, we both want to commit. So I'm a little bit faster, obviously. So I commit mine first, and then Duncan, just to make merge conflicts, this is the process you do. He would pull my commits and then push his commits. And at the end of the day, we'd have a timeline. Essentially, if I condensed it down visually, it would look something like this. Duncan and my commits, both in the history. I've shown it showing it as if it was a timeline, but obviously, if you were looking at a diagram, they'd be spaced out evenly probably. But this would be the commit history. We both have laptops, so what we do is we jump onto a modeling machine, pull those changes down onto the modeling machine, which is really easy. You don't need to do any copying. You can just use the version control software. It's running, brilliant. We have time to go to the pub, you know. But then I thought, when I was writing this, I thought, oh, well, maybe that's not what you want to do. Maybe you want to grab a wine and some cheese and a baguette instead. Maybe the British pint doesn't quite work. Moving on to the example. Another example. This one is a little bit more pie in the sky, I think, a little bit more idealistic, but it's just an idea I had with model hosting. So in this example, I was considering what it looks like if you wanted to host a model that could be used by multiple people rather than just internal collaboration. You may want to say, hey, some council or government authority or some whatever holds a model of a catchment. So this happens a lot in Australia. I can't speak to even UK, but some council in Australia or authority will hold a model, and then consultants will actually grab the model when there's a development application or some infrastructure. Sometimes they have to pay for it, sometimes they don't. Doesn't really matter, but essentially they would use the council's model to then do their application, their testing. So I thought, hey, maybe this could be all done through something like GitLab or GitHub. So you could have an existing branch of the model repo that holds the existing landform as it currently is. And you could also have some sort of approved development branch. So the same model repo, but we're using different branches in this case. And the approved development branch might just represent a 2-year horizon of approved developments that could be in the catchment soon, and represent some future scenario, which is really useful when you're doing future planning, climate change, and all that, to have some idea of what the landform is going to look like in 2 years' time, even if it's loose. So you'd have these two branches, and say someone comes along and says, I want to build a house or a bridge or some infrastructure which involves a bridge over the waterway. You need to go through some modeling to make sure we're not doing anything wrong, like making things worse. Pretty standard stuff. Well, then they get me to do it. I would fork this timeline, this branch, into my repository, or however they want to do it. Fork is a new word, I know, but it's essentially when you grab someone else's repo and bring it into your own repo so you can do work on it separately. I would come along, I would have so many commits, I would work on the model until we're all happy with it. That might be 3 commits, it might be 100 commits, who knows. Go through of course, the relevant application phases and approvals and review and stuff. And when everyone's happy with it, I essentially just push my changes, or it's called a pull request, where I would want to merge my repo into the original repo. And that would, of course, require approvals and stuff eventually, but hopefully that all goes smoothly, and that will be pushed into the branch. And then all of a sudden, this branch here is up to date with what is potentially forecast in the future. Eventually, that, say it's a bridge, would get built. You'd have to then do some as constructed modeling, because obviously design and construction, sometimes they differ conceptually to actual construction. So again, you'd probably pull from the existing, do your modeling based on as constructed drawings or design or whatever, and you'd then push your changes into the existing branch. So then you'd be updating the existing branch. And this would go on, like these can happen simultaneously. Another developer might come along and want to build a house somewhere, and so on and so forth. So these branches would be kept up to date as these approvals and development came along. And you could also see a history of the entire model. So someone at this point in time can go, oh, okay, like let's have a look at the history and see, the history of the model. And this would be a very easy thing to do. It's not like likewise up here, it'd be just what's been approved and where did floods, did it used to flood in this location? If you get someone coming, hey, like it's flooding here now, but it wasn't before, you could go back in time to see if that's true, or at least to see if the modeling says it's true. Or in the existing case, you go back in time, and that would be incredibly easy. You could even look at the commit messages or the pull request to see exactly when certain things happened. And yeah, I think it would be almost too easy to do that in this version control. Okay, so I'm just going to quickly sum up some of my takeaways when I was doing this testing, because this was all new to me in terms of using it for model building. Obviously, I've used it quite a lot in the past for software development. But so some of the pros I found were obviously folder organization, cleanliness. You don't have a million files with different version numbers in your modeling structure. It's literally just one set of files, one TGC, one TCF, one Geopackage, one TIFF file. All of that is just one of them. You know exactly what files are required for modeling because there's only one version of them in the model folder. There's far less manual versioning. You're not copying files, changing their names, making sure to remember to update the TGC name in the TCF and so on and so forth. So there's less chance of errors and reruns and things like that. Mandatory logging. So every time you make a commit, you have to say what you did. So modeling log is no one's favorite part of modeling, but having mandatory logging in commit messages means that you pretty much have a history of the model by default. And that's, of course, presuming that the commit messages are good and meaningful. Obviously, that's up to the people writing the commit messages. There's a good quality of control for simultaneous model building. So as I demonstrated, Duncan and I could work on the same model, or we could bring someone into the company or into the project, and they can just easily pull that model down and start working on it. They don't need to, go onto the network and figure out which modeling files are useful and which are not. Model storage is really nice. So having something like GitLab and GitHub is just quite a nice way to view the history of the model. And it has, like I said before, has a number of other useful features around it, like ticketing systems, job boards, and issue trackers, where you can really assign people tasks and get them to go off, and you can have discussions on those tasks. So it makes model review processes probably a lot nicer as well. Model hosting as well, which is what I just showed you, which is, I think, a bit more of a dream than a near-term reality, but something that would be really nice. Easy to push-pull makes moving models onto modeling machines and using the right version of the model very easy. Like, you don't have to worry about copying the right files, copying the right updates. You don't need to go through the files and figure out which ones have changed. Very easy. Distributed, so Git's a distributed version control, which makes this model backup inherent in the system, because you might have a version of the model of the repo in a number of different places. In terms of TUFLOW, the workflow does not change. In fact, I think it's enhanced in the changes that are there. And you get to use geopackages, obviously, which are not nice little shape files, in my opinion. Cons. So there are cons. It's a fragmented system, maybe, with 2 different repos, which is annoying. And then you have unversioned files alongside those. So yeah, you could consider it fragmented, mainly because of the 2 repos in my mind. And with those 2 repos becomes maybe a commit alignment problem. So, you know, going back in time, you have to figure out which commits from which repo line up, which would be maybe a little bit painful. Maybe a solution to that would be to simply have a comment in, say, the TCF and maybe one of the geopackage layers that always gets updated when you make an update. So essentially, you're committing both repos always alongside each other. Another con I thought of was maybe results are being overwritten. So if you're using the manual method, you're renaming the TCF, you're actually getting the TCF result files will then therefore have different names. So it won't overwrite results when you run a model. Obviously, if you're not updating result TCF names, you're not going to have a history of results if you want them. Another solution to that would be similar, extending the previous solution, is you'd have something like a variable called version in TUFLOW, which you can do by set variable, and you'd have like a number, and then essentially in the output folder, you just reference this version, and you could do that with the log folder and the check files as well. And so every time we ran it, as long as you remembered to increment this number here, it would write the results to a different location, which means you'd keep the old results as well. The risk. So there's always a risk. KART is relatively new, and it is open source. So you always run the risk with these new open source projects, or with any open source project really, that whoever's developing it could get bored, just get fired from their current job, so they can't just go off and do these side projects, or they might stop getting funded by some avenue, whatever, if they're getting funded at the moment. So there's always a risk with open source that all of a sudden it's just going to stop. The party's going to stop and you're going to have to go and pay for something, or you're going to lose a lot of workflow. Git, I'd say, is pretty safe. is used by a lot of people in software development, and probably, you know, funded by things like Google. I don't know if that actually is, but Google does tend to fund things like Python and other open source projects that they rely on. So Git's probably pretty safe. KART, less safe. You might want to wait to version 1.0, but that doesn't necessarily make it safe. But at least it locks down some of the workflows will be locked down at version 1. My wish list. So I wrote this wish list just to caveat this last year, about this time last year, maybe a bit earlier. My first wish list is that text files were in KART, which means essentially you can move the control files to KART, which means you could just have one repo. You don't have to have two repos. That's actually on the KART roadmap, so I'm giving that like a maybe, but hopefully it will happen. I'd like to see submodules in KART. So Git has this thing called submodules, where you can essentially have a module, a repo, and then have sort of these sub-child repos of the main one, which just means it references these other ones, which means they sort of are collected together. I think that would be really nice to have in KART as well, for a number of reasons. And finally, there's a few small things when I was setting it up around authentication prompts in Windows command prompt, which I think are done. So I think that's largely been eliminated from my wish list. But yeah, that's the end of the presentation. Hopefully everyone understood my accent, everyone understood what I was saying. But yeah, that's the end.
Yeah, thank you, Alice. Yeah, is my mic activated?
Yes.
Great. Yes, thanks. It's very interesting. Huge possibilities about making things a bit more tidy on our TUFLOW models. Before letting the people ask some question if they have, I had a few questions or comments. It's very nice, but what could go wrong? Apart from the result being overwritten, because you've talked about that, but
I'd say the first thing that comes to mind is Git is maybe a learning curve. Just because I know when I first got into it in software development world, and we also now use it for a bunch of TUFLOW documentation. You can really mess up a repo. Well, seemingly it's always recoverable, almost always recoverable. So I wouldn't worry about it too much. But you end up doing something silly, and you're trying to fix it, and you're just Googling random Git commands and just chucking them in and hoping things get fixed, which is risky. So I know that is something that can happen, but I think once you get over that hurdle and just the slight workflow changes, apart from KART being the risk of falling apart or not being developed anymore, I think that's it, really. I don't think many people move to Git in terms of software development or documentation and regret it. I don't know. What do you think, Duncan? I don't know if you have any comment on that.
No, just what you were saying about that little bit of an additional learning curve is the main thing that I can think of.
Yeah, it's interesting because it leads to my second question. Yeah, it seems very developer oriented. So if the modeler don't have any have a small background into coding, yeah, it can be a bit scary at first, I think. So it leads to your comment about the learning curve, which is of course a bit difficult, but
that's why I showed it with when you're using, and this is not just for like only hardcore developers don't do this. Using the GUI, so using VS Code to interact with Git, using the KART plugin to interact with Git. So when I do coding, I don't sit there writing out Git commands through the command line because I use the GUI because I know things can go wrong. So that's hopefully reduces the learning curve a little bit. As long as you have the workflow of committing, pushing, pulling down, you're pretty safe, I think.
Okay.
I think the other thing there in terms of the learning curve, and I speak from my own experience here, is you don't have to go for the all singing, all dancing approach to begin with. I only use KART, for instance. I don't do any of the VS Code stuff. I'm quite happy with the version control on that I have already existing, using duplicated files on the text file side. So it is, if you want to do it, stick with the bits that the geopackage side, the KART side, get to grips with that, and then the text files can come a bit further down the line.
Right, because I guess that the biggest benefit is mainly on the GIS files, and then you can of course have nice benefits, very good benefits on the text file as well, TCF, TGC, and so on. But yes, we make a lot more changes in the GIS files, adding some things in the model and so on. So I think it's a good comment. Even if I found the VS Code part very interesting. I did not know. Well, I haven't identified that we could modify and update our text file with this tool. And yes, for the people coming from the coding background, it's very interesting. Yeah, that's nice. I have a few questions. I take the opportunity to have experts with us. So, it's more a question about Geopackage. Something that I've asked already to Duncan. Would there be any possibilities, or plans to store the tables of TUFLOW materials, for example, soil, into a GeoPackage table? Because it seems that it's already been done on the swim part. Tables from swim are stored in the GeoPackage, no?
I think they, excuse me, they are only as an interim. So I think we use it in the plugin, I think, to store stuff, but then it writes it out to the input, the swim IMP file, which from Qgis to do the actual run of TUFLOW. So TUFLOW doesn't actually read anything from the GeoPackage that you set up in the plugin for swim, because it writes it out to an input file. But yeah, no, I think because it's an SQLite database, databases were designed, well, most databases were designed to hold tables. So it is like the perfect mechanism to store material entries, or databases and soil database files. So yeah, the answer is that can be done. And I think it might be a ticket somewhere in our development list to do that. Yeah, I think that's definitely possible in the future.
Okay. Claire, you seem to have a question. I don't know if you can.
Yeah, I can hear you. I have two questions. The first one, I'm not sure I understood correctly how GitLab works with KART, because I have tried to use KART a few sometimes, and everything is stored locally on my computer, and if I use GitLab, it's stored on their server. Is that right?
Yes, it's stored on the GitLab server cloud somewhere. Yeah.
Okay, so
Yeah.
the only difference is that it's not stored locally.
Yeah, but whenever you want to run a model, you have to grab it from GitLab, right? Pull it, update it, and then have it locally on your computer before you run the model.
Okay.
Does that make sense? Does that answer your question?
Yeah. I just wasn't sure what was the role of GitLab, but it's just for storage.
It's for storage, and then also other people can access. So if you're working on the model with anyone else, they can go get the model. They don't have to go into your computer, obviously, to grab it. So it's just a storage location where everyone can get to it, and it's sort of like the master copy in a way, and that is retained. So you might delete the model from your computer at some point in the future, then need to go back a year later to grab it. So that would be where you grab it from.
Okay. Thank you. And the second thing, it's about the outputs of the models. Is there no way to version it somehow? Because I'd like to, when I run my model, I'd like to link what inputs I have to the outputs, and when I come back to my previous inputs, it would be nice to know what were the outputs at that point.
It definitely can, depending on the format. So I would just use Git personally to do it. And the thing is, though, if they're not plain text files, which some of the outputs are, but some are not, some are GIS files and some are like the XMDF files, Git doesn't really do a very good job at telling you what the differences are, but that might not matter because it's just, you just want a result that's associated with it rather than a proper like version control where you get to go into the file and see what the differences are. So yeah, you could, there's nothing stopping you from doing that. They're just also very big, that's all. So you might just end up having a large, out of control database on the cloud if you're storing gigabytes worth of results on there, and you might start paying a lot of money for that, and it might take a long time to pull down anything. You might have to sit there downloading gigabytes of data. It might only happen once, but yeah, typically you wouldn't do it. But then again, typically in software development, when you compile something, it might take at most an hour to compile, maybe more. Whereas with modeling, you might do a 17-hour run, so you might not want to just regenerate results all the time. So it is a little bit different from software development, I acknowledge that.
Okay.
Maybe a small comment which may be linked with the question and something related to a discussion I had with Duncan a few calls ago. I don't know if there is a way or if there is something planned eventually in the plugin have the kind of visualization that we have now in HTC RAS with the compare model tool, which is very new. I think it's the last version. You have a visual graph linking your boundary condition, your flow files, your geometry, your plan, terrain, and so on, to your results. And when you multiply the scenarios, it's quite easy to get lost if you don't have this kind of tool. We can follow it obviously in the log file, in the Excel file which is provided as an example. But is there any possibilities with, especially with this kind of version control tools, to link which TCF was called with which TGC and so on?
Yeah, I mean, it would be possible, and I'd have to go look at what that is actually. But yeah, definitely, almost anything is possible, and if we get enough demand for it, we have to just dedicate time to it. But yeah, we could definitely have a look at that, and I think some of the stuff that's sort of in the works at the moment with Python libraries and stuff which we're making might make it a little bit easier to do this kind of thing.
Okay.
But yeah, if that's something that is worthwhile, we can definitely have a look.
Well, I guess it could be of benefit for, especially for people beginning with TUFLOW, because we have always, as for coding and as for everything else, you have the expert which kind of keep tracks of what is doing in the matrix, and maybe the beginner can be a bit frightened by the text files and so on. So I don't know. I've sent in the conversation an example of the tool.
Yeah. No, I think I've seen that, or at least one of the earlier iterations of that.
Because I think it seems that the principle is that the HGF file keeps tracks of what has been called to produce the results, and then we kind of displays it in a friendly way.
Yeah. I mean, you could probably do a basic version of that just by using the TLF, and you just grab relevant things from the TLF. You wouldn't have all the options there. That's all. You just have the actual things that were called. Though, if you wanted like all the options, you'd have to code it. You have to start from the TCF probably and start looking for things. Yeah.
Okay. Yeah, I didn't think about the log file, the TLF, but yes, that's nice. And maybe a comment for people listening. I encourage you to update regularly your plugin, because the plugin moves very fast, and you have very nice additions regularly. One of the nicest one, like lastly, was the runner, which was integrated directly into the plugin. It's very nice.
Thank you. Yeah, there's a development version of the plugin as well that you can, if you want to be on the absolute like bleeding edge, you can go down. Like we have somewhere on the wiki page. If you go to the plugin wiki page, there should be a link to a wiki page that says how to get hold of the development version of the plugin.
Okay.
You can install that. It's very easy to install, and if you find that there's any bugs or anything, then you can just go see if it's just double checking it's been fixed already. Especially when Qgis releases a new version, they like to break things for me. They like to make my life really hard. So I try to get some updates into the development version first before obviously releasing a version to the repo. So yeah, definitely check that out. I could probably post a link to that in the chat potentially.
Okay. And anyway, we'll share materials of the webinar afterwards. So
yes, I'll send it to Duncan, and hopefully Duncan can.
Okay. Any other question from people online? Maybe another question on my side, because the collaboration part is very interesting, between inside the team or even with the client. I didn't identify these possibilities before. Do you have any rough idea of the cost of hosting for, let's say, a quite large model for a city or city council, or do you have any feedback on this so far?
I have no idea about costs. Sorry. Yeah.
Okay.
I think just from what I've heard, so don't take this as fact. Probably GitHub offers better pricing than GitLab.
Okay.
But they're definitely free versions, but they may have a storage capacity, and they also may not let you make the repo private unless you pay. So it may be for a certain size. So it may be that you can do a big size, but then you may have to make it public, which you don't want to do, obviously. So
Right.
yeah, just double check. I really am
Okay.
not the right person to ask for those kind of questions.
Yeah, what you say about the public and private repository is important because, yes, in some case we can't share the data widely.
I'd also be a little bit careful with GitHub. This is getting a bit technical now because that's where Copilot scrapes GitHub, because it's owned by Microsoft. It's a GitHub product. So Copilot is like an AI tool that helps you code. But it learns from GitHub repositories. So you may just be a bit careful. Not that anyone's using TUFLOW to code at the moment, but if enough people put their TUFLOW model on GitHub, it may start getting confused and start writing out modeling files for some region in France or England or something. I don't know. Australia looks like it.
Yeah, I can see where it will lead. Yeah. Right. And maybe a comment also on the collaboration. As you said, it's with this kind of tool, it's much easier to switch between your laptop when you're editing your model, your big machine where you're running everything, and it opens to facilitate widely the sending the model into cloud as well.
Potentially, yeah, because you can on a cloud instance, you can then just pull the origin onto the cloud instance and run it. Yeah, that's right. It would be so easy to do that.
Okay. Nice. Thank you very much. I don't think that we have more questions. Anything to add?
No. I hope you found it useful, and maybe give it a go. I don't know. I know there's a few people giving it a go after I gave a similar presentation at the TUFLOW user conference. Some people went out there, but I don't know if it's very widely adopted yet in the industry to do something like this.
I think that sorry, go on, Duncan.
I was just going to say, and if you give it a go, feedback to us, because it's always useful to know if these things are useful, and whether we should look into developing tools to help the process.
Okay. I can see that the industry needs a kind of cultural shift, but I'm kind of I'm getting old, so maybe the new generation of modeler, like people we have in our team. I was thinking about Zakaria and Maria, which are following the webinar. I think they live part of their life in GitHub, so maybe there will be the solution for the moving to this new method.
Yeah, definitely lead the industry.
Yeah.
Yes.
Thank you very much.
My pleasure.
Super. Thanks all.
And next webinar will be on catch after the summer. Duncan? Yeah.
Hopefully, yeah. That sounds good.
Great. Thank you, everyone.
Thanks all. Bye.